warahmatullahi wabarakatuh. So today our group will be presenting about dynamos. But first we will go over the fundamental physics concept that actually apply to dynamos in general. So the first is a Faraday's law, which governs electromagnetic induction. In essence, EMF is actually induced when a conductor is put in a changing magnetic field. So Faraday once did an experiment. So in that experiment, a main coil is wrapped around an iron ring and is linked to a switch and a battery. So in the meantime, a secondary coil is wrapped around the ring and linked to a sensitive emitter. When we close the switch, we see that the current reading will jump for a brief while before returning to zero. Even when the switch stays closed, the current measurement in the secondary circuit remains zero despite the fact that there is current in the main circuit. So when the switch is open again, the current reading jumps with the opposite sign as before and then returns to zero. So we can observe from this experiment that current is produced in a loop when the magnetic flux across the loop varies over the time. When the switch is closed, actually a current flows through the primary coil. So this current creates a magnetic field in the iron of the ring, which changes from zero to equilibrium once the switch is closed. The changing magnetic field creates a current via the secondary coil. So the magnetic field returns to zero when the switch is closed and there is momentary induced current in the secondary coil in opposite direction. So we can see that an EMF is induced by a changing magnetic field. So next, we're gonna look at the Faraday's law of induction. So actually EMF equal to the changes of magnetic flux over the changes of time. So if a coil consists of n loops with the same area, there is a magnetic flux through one loop and EMF is induced in every loop. The magnetic flux through the loop equal to BA cos theta, which is B is a magnetic field, A is area, and theta is the angle between the magnetic field and the normal to the loop. So there are several ways that EMF can be induced. So firstly, the magnitude of magnetic field can change with time. The area enclosed by the loop can change with time. The angle between magnetic field to the loop can change with time, and the normal or any combination as stated can occur. So then we're going to take a look at Lenz's law. So this law stated that induced current in a loop is in the direction that creates a magnetic field that opposes the change in magnetic flux through the area enclosed by the loop. To have a better understanding, we can analyze the figure shown. So as the bar moves to the right, the magnetic flux through the area enclosed by the circuit increases with time because the area increases. So the magnetic flux due to an external field directed into the pitch is increasing. So to oppose this change in the induced current in the circuit must produce a field that directed out of the pitch in the area enclosed by the circuit. So importantly, the induced current in the loop of the circuit must be directed counterclockwise when the ball moves to the right. So if the ball moves to the left, the external magnetic field through the area enclosed by the loop decreases with time. So the field is directed into the pitch, so the direction of induced current must be clockwise. So actually, what is a dynamo? So dynamo is an electrical generator that utilizes a commutator to generate direct current. So dynamo is actually a device that converts mechanical energy into electrical energy. So dynamos were the first electrical generators utilized to supply power to industry, as well as they serve as the platform for several subsequent electric power conversion types of equipment, such as the alternating current, AC alternator, electric motor, as well as a rotary converter. So next, Izzatul will explain more details about the dynamos.
Thank you, Kama. So now I will explain about who invented the first dynamo. So in 1918s, Michael Faraday invented the first dynamo. Dynamo is the original name for electric generator. Electric generator is a machine continuously converting rotational mechanical energy into electrical energy. It consisted of a copper disc that rotated between a poles of magnet. This was not a dynamo in technical sense, as it did not use a commutator. However, Faraday disc generated very low voltage because of its single current path through the magnetic field. Faraday and other scientists found that higher, more useful voltage could be produced by winding multiple turns of wire into a coil. Wire windings can be conveniently produce any voltage desired by changing the number of turns, so they have been a feature of all subsequent generator designs requiring the invention of the commutator to produce direct current. So, in this slide, you can see inside a generator which consisting a stationary structure called a stator, which provides a constant magnetic field, and a set of rotating windings called the armature, which turns within that field. And we also can see the commutator. The commutator was needed to produce the direct current, so commutator is a very important part in a generator. So next, I will explain about why dynamo generates electricity. An electric motor is essentially just a tight coil of copper wire wrapped around an iron core that is free to rotate at high speed inside a powerful permanent magnet. When you feed electricity into the copper coil, it becomes a temporary electrically powered magnet. In other words, an electromagnet. And it also generates a magnetic field all around it. This temporary magnetic field pushes against the magnetic field that the permanent magnet has created and forces the coil to rotate. By a bit of a clever design, the coil can be made to rotate continuously in the same direction, spinning round and round and powering anything from an electric toothbrush to an electric train. So last but not least, the application of dynamo. By using the concept of electromagnetic induction, we can find dynamo in various machines, especially machines that converts mechanical energy into electrical energy. So here I have some example that use the same concept as the electromagnetic induction. So that's all for me. I will pass the next part to Nasha. Thank you.
Thank you, Izzatul, for the explanation. Now, I'm going to continue with my part. So, when do we use dynamo in our daily life? One example that we can take is dynamo in bicycle, which also use the concept of electromagnetic induction. This process is also essentially the same process that occurs in any electrical motor. So, how does it work? When a bicycle starts moving, the top of the dynamo touches the rim of the tire. A direct current then will be produced. A bicycle dynamo has one or more permanent magnets with coils spinning inside their poles. Thus, when the coil spins in the magnetic field created by the magnetic flux begins to change through the coils, resulting in an electric field that finally regenerates electric current. This involves Faraday's law and Lenz's law. As a result, the lamp of the bicycle will light up. Faraday's law occurs when the magnitude of EMF is produced, while the Lenz's law only involves to determine the direction of the current flow. So there's advantages and disadvantages when using a dynamo. Let's discuss about the advantages first. The first one, dynamos have no running cost. That means if we bought a dynamo, we can use it for a long time. The power from the dynamo do not run out too. As long as the bicycle is moving, there will be enough lighting. The last one, it is environmental friendly. Dynamo do not use toxic chemicals to dispose. So let's discuss about the disadvantages when using a dynamo. The first one, they can only be light if the bicycle is moving. Before the rider starts moving, there is no light that will be produced at all. The second one, whenever the speed reduces, the lights become dimmer. That means the rider has to maintain a certain speed for there to be enough light. The last one, it requires energy from the rider for there to be a light. He has to keep on pedaling to maintain the motion of the bicycle. In conclusion, the concept of electromagnetic induction according to Faraday's law has been applied on dynamo. From the explanation before, we know that electromagnetic induction is the creation of an electromotive force EMF by way of a moving magnetic field around an electric conductor, and conversely the creation of current by moving an electric conductor through a static magnetic field. We can relate this concept with some of the Islamic perspective too. One of the lessons that we can take is the energy that we need to produce by cycling the pedal of the bicycle ourselves to gain the electric current. We can relate this with our daily life, which we want if we want to gain something, we have to make an effort for it. Nothing will work out if we tend to give up easily and we won't achieve anything in this life. Allah Subhanahu wa Taala will reward those who work hard and always remember Him whenever they want to achieve their goals. Hence, we must do every task in our life as well as possible to achieve our goals successfully. That's all from us. Thank you.